Hi everyone, today we are going to discuss from question number 24 of miscellaneous exercise, and in the last class, okay, for the miscellaneous we have discussed up to question number 23, and we'll be selecting some important questions today, and we'll just continue, okay, and this is question number 24. These questions, the questions that today we are just going to discuss are very, very important. And when you just see the question, sometimes it seems like, okay, the questions, in case if you have not done before, then it seems like, okay, expression is big, how to integrate. Actually, these questions are very, very simple. In case if you master the simple trick, okay, that it's linked to the question. So we'll continue with this. This is question number 24. So most important step of this question is this. Okay, x to the power 4, and from this is under root x square plus 1, we are just going to take x square common. So if you take x square common, so it will be 1 plus 1 by x square. And we're just going to simplify this. So it's log x square plus 1 by this minus 2 log x, so it can be written as x squared, so it can be written as x squared. So it's log a minus log b formula, and this is dx. So you can cancel this x to the power 4, so it's x3. And we'll just need one more step, and 1 plus 1 by x squared then, and this expression, that is x squared plus 1 by x squared, also will be writing in the form of this, that is 1 plus 1 by x squared. So that can be written as log. So if we divide this binomial x squared plus 1 by x squared, it will be 1 by 1 plus 1 by x squared dx, and divided by x3. Okay, and now next step is that we are going to substitute 1 plus 1 by x squared as t. Okay, so if we substitute, let 1 plus 1 by x squared is equal to t. We'll just, if we differentiate this is minus 2 x to the power minus 3 dx dt. Fine. So now we'll just can write this expression as dx by x3 equal to dt. So this expression, we got a value for dx by x3. If we go back to the previous page, so there is a term dx by x cube. So you got the value. So we are assuming under root, this is 1 plus 1 by x squared is t. So it will be square root t and log t. And in place of d by x cube, so you can just substitute this. That is di by x cube will be dt by minus 2. So we can just continue with this. So this will be root t, and this is log t. Fine. And only step is left out is dx by x cube. So dx by x cube can be replaced as dt by minus 2. Fine. So it's becoming this simple steps. Or just 1 by minus 2, we can take it out. Fine. This is root t and log t dt. So, and we'll follow the steps. It's a very simple step. We'll just follow integration. We'll just integrate this by integration of parts. So if we just continue with this integration by parts, so here root t and log t, so naturally log t will be the first function, and we'll just integrate root t. So if we integrate root t, it will be t to the power 3 by 2 by 3 by 2 minus. So this is the first function, so we'll just differentiate this 1 by x. The way we have integrated this particular root t, so if we integrate there also, this will be t to the power 3 by 2 by 3 by 2 dt. Fine. And next we'll just continue this. Okay, and next is minus 1 by 2. Okay, and this will just simplify. This we can just write as 2 by 3 t to the power 3 by 2. If we just arrange in a proper order, t to the power 3 by 2 log t. Fine. And this also just arrange it. It's minus 2 by 3 minus 2 by 3, and this is, so just cancel x to the power 3 by 2 by x. So if we cancel it, this will be root x. Fine. If we cancel this, and this is dt. So we have seen that integration by parts also for this function root t and log t is very, very simple. And we just individually multiply by minus half. So if you multiply by minus half, so those 2 will cancel out, we'll get minus 1 by 3 t to the power 3 by 2 log t. Done. Next we're just going to multiply this term by minus half, so minus minus and plus, and 2 will get cancelled out. We'll just get plus 1 by 3. Okay, we'll just integrate this. So if we integrate root x, this will be x to the power 3 by 2 and by 3 by 2 plus 3. It's almost done. We need to only substitute the value. So it's not root x, it's to be t. Okay, this will be root t, fine. So it should be t to the power 3 by 2. Okay, this is t to the power, this is 1 by, this is, okay, fine. This is, I have written log t, differentiation is 1 by x, it should be 1 by t, and this should be t to the power 3 by 2. Okay, please correct this. Next, and this is minus 1 by 3, t value, what is the value of t? T value is 1 plus 1 by x squared to the power 3 by 2 log, and t value is 1 plus 1 by x squared. Fine. And if we just multiply t by t, it's 9, and 2 will go up, it's 2 by 9, and t value will just substitute 1 plus 1 by x squared and 3 by 2 plus c. So this is the answer for this particular question. Okay, fine. And we'll just move to the next question, right? This is 25. From this question onwards, okay, in the miscellaneous, that question start for definite integral. Okay, definite integral start from this particular questions. So how to solve these questions, and by if you just observe this particular function ex and 1 minus sin x by 1 minus cos x, so it should come to your mind important form, standard integral, that is ex fx plus f dash x. This form, integration of ex fx plus f dash x form. You can just write here e to the power x. There is a very important standard form in integrations, which is in the form of e to the power x fx plus f dash x. Right? Like this question we have discussed before, and in case, and if you know it's not given directly, in case just try this one in this form, and if we are successful to write this expression as a fx plus f dash x, so your answer is very simple. Your answer is always ex and fx. Only thing that one function is to be the differentiation of the other. Okay? So since these are the type of questions we have discussed, I'm not going to discuss all this now. So it's pi by 2 to pi ex. Fine. We need to work on this. We'll just simplify this. So if you simplify this, we know that 1 minus cos x can be written as 2 sin square x by 2. Fine. Right? 1, then sin x can be written as 2 sin x by 2 cos x by 2. Done. And dx. Okay. Now pi by 2 to pi ex. So what I'm going to do is, we'll just divide 1 by this. Okay, 1 by 2 sin square x by 2. So if we divide this, it will be half, fine, half, and cos x square x by 2. This is the first term. Minus, what's the second term? This 2 will get cancelled out. 1 sin x by 2 with 1 sin x by 2 will get cancelled out. Only cos x by 2 and sin x by 2 will be left out. That is cot x by 2 dx. Now let us check, right, whether one function is the differentiation of the other or not, right? So what is the differentiation of minus cot x by 2? We know the differentiation of cot. Okay, differentiation of cot x by 2 is minus cos x square x by 2 into half, right? Cot x by 2 differentiation is minus half cos x square x by 2. Now here, if we consider minus cot x by 2 as fx, that is, if we consider that minus cot x by 2 as our fx, now if we differentiate this, so minus is there. From cot x by 2, another, if we differentiate, there will be another minus sign, so it will be plus, so it will be cos x square x by 2, and since the coefficient of x is half, So we need to differentiate x by 2 once more. This is half. So half cos x square x by 2. So exactly like this function. That means if we differentiate this minus cot x by 2, we get half cos x square x by 2. So this is in the form of ex fx plus f this x. Fine. Exactly. So we can identify easily that here fx is minus cot x by 2. And now we can directly write the answer for this. So what will be the answer for this particular function? Okay. We can, the answer for this particular function is ex fx. So this is ex and fx is minus cot x by 2. So that means we are converting this one to the standard form and we got the direct integrations. Now only thing is left out, we need to substitute the limits, that is pi by 2 to pi. Fine. I hope these things are okay, are very simple, and I've just explained each and every point regarding these questions. Now next step, we're just going to substitute a value. So if you substitute, so we'll just take minus out. So if we substitute pi, this is e to the power pi cot pi by 2, fine, minus, okay, minus, we'll just substitute e to the power pi by 2, fine, e to the power pi by 2, and cot, in place of x if you substitute pi by 2, so it becomes cot pi by 4, done. Okay, and now this is minus e to the power pi cot pi by 2, and it will be plus e to the power pi by 2 cot pi by 4. In fact, like from there you can directly write the answer. Just I'm writing one step extra, right? So we know that cot pi by 2 is 0. So this term will be equal to 0, cot pi by 2 0. And this is cot pi by 4 is 1. So finally, our answer will be e to the power pi by 2. So as you have seen that in these questions, the moment you can identify that what form this question is given, and the later part, okay, the remaining steps, it's become very simple. Okay, and next we are going to discuss another very important questions, that is this questions, that's question number 27. So how to solve these questions, right? And this question is important only because of this term 4, right? So we'll just start these questions like that. We'll just divide numerator and denominator by cos square x. Okay, if we divide numerator and denominator by cos square x, it's only 1. This is 1. This is 1 plus 4 sin square x by cos square x, that is tan square x dx. Fine. So we got the steps. Now next step is, like how to go ahead of this particular questions. We're just going to substitute tan x equal to t. So let tan x equal to t. So if we substitute tan x equal to t, so sec square x dx equal to dt. Fine. So this implies dx equal to dt by sec square x, but sec square x can be written as 1 plus tan square x. Tan x is c, so it can be written as 1 plus t square. So we got the value of dx. So this tan square x, tan x will substitute t, and we got the value of dx in terms of t. Next, we need to, since we are using a new variable, okay, t, so this limiting value 0 and pi by 2 also to be written in terms of t. So if x equal to 0, so if you substitute x equal to 0, so tan 0, that is t equal to 0, because tan 0 is equal to 0. Now if you substitute x is equal to, right, x equal to pi by 2, x equal to pi by 2, so it's tan pi by 2 is an infinity, so t is equal to infinity. So therefore limit goes from 0 to infinity. Okay. So let us continue. I equal to 0 to infinity, and this is 1 by 1 plus 4t squared, and we are going to substitute the value of dx. Okay, dx value dx value, we got dx value is dt by 1 plus t square. Remember this. Fine. Dt value is, dx value is dt by 1 plus t square. Yes. The question is becoming in this form. Like it's converted to this form. So if we just write in a simplified way, this is 0 to infinity dt 1 plus t squared and 1 plus 4t squared. And we know that this integral, right? This integral to be done, this is dt, and the denominator there is a product of two terms, 1 plus t squared, 1 plus 4t squared. So to integrate this type of questions, so we'll have to take help of the partial fractions. Now this particular rational function, that is 1 by 1 plus t squared, 1 plus 4t squared. Okay, we can just write in a simplified manner with the help of partial fraction. So we'll just move to partial fraction now. Now 1 by 1 plus t squared, 1 plus 4t squared. Because the moment you see this expression, you know that there is no direct formula, okay, to solve these questions. Right? So we have to follow one standard method, right? 1 by 1 plus t squared, 1 plus 4t squared. So there we'll just follow a simple trick. So you have seen that the power of this is 2, right? So if we directly go for partial fractions, the things becomes very difficult, because here the power is 2, and for the first term, second term also the power of t is 2. Okay, so we'll just try to avoid the t squared power. So what I'm going to do is, we're just going to use a new variable, 1 plus y. Just we'll replace it, that is only, this is algebra part. The t squared is just replaced by 1, okay, and 1 plus 4y. So we are just replacing t squared by y. Now we are going to separate these terms with the help of the partial fraction, 1 by 1 plus y into 1 plus 4y. Okay, so for that we're just going to follow this method. Okay. Let 1 plus y, 1 plus 4y, fine, is equal to a by 1 plus y plus d by 1 plus 4y. Now things will become very simple the moment we are trying to separate the terms in terms of y, not in terms of t square. So the next step is 1a 1 plus 4y and d 1 plus y. Okay. So we'll just throughout this particular steps, we are multiplying by 1 plus y into 1 plus 4y. So if you multiply this term by 1 plus y into 1 plus 4y, it becomes 1. And each term we are multiplying by 1 plus y, 1 plus 4y. So if you multiply this one by 1 plus y into 1 plus 4y, this is 1 plus y, will get cancelled out, you'll get 1 plus 4y. Similarly, this term, this is b by 1 plus 4y, also you are multiplying by this term. So, and 1 plus 4y will get cancelled out, so b will be multiplied by 1 plus y. Now, important is that we are going to get the value of ab. So for this, very simple steps, okay, we just put y equal to minus 1. If we put y equal to minus 1, and this particular term will become 0. Right? If it is, it becomes 0, so it's 1, and this y, if we substitute minus 1, it's 1 plus 4 into minus 1, that is 1 minus 4, then it gives us minus 3. So it's minus 3a. So this implies a equal to minus 1 by 3. So we got a value of a. Similarly, if we put, right, by putting minus 1, y equal to minus 1, we are just converting this one, b 1 plus y becomes 0, then it becomes easy to calculate a, and now we are going to make this term 0. So for that, you need to substitute y equal to minus 1 by 4. Put y equal to minus 1 by 4. So if you substitute y equal to minus 1 by 4, it's 1. This term will become 0, and this is b 1 minus 1 by 4. Fine. So this gives us what? This gives us, that is 4 minus 4 minus 1 by 4, that is 3 by 4b. 3 by 4b. So therefore, what is the value of b? b will be equal to 4 by 3. Okay. b is equal to 4 by 1 equal to 3 by 4b. So b is equal to 4 by 3. So you got the value of a and b. So a is equal to minus 1 by 3 and b is equal to 4 by 3. So this can move to the next slide. Fine. So this one we have written in the form of a by 1 plus y, and a value is minus 1 by 3. Fine. 1 plus y. And b value, okay, we got it 4 by 3. 1 plus 4 by 3. So have you seen? Right, these particular expressions can be written in the form of this. Now we'll just replace y by t square. Fine, y by t square, and then this particular term, this particular expressions becomes easily integrable. We'll just continue now. So if we continue, we can write these expressions in this way. This particular expressions can be written in this way, right? So it's 0 to infinity. Instead of these particular expressions, we can just write minus 1 by 3, 1 plus. Remember this, that you are integrating in terms of t. So while writing, you need to write in terms of t. Y equal to t square. T square plus, okay, this is 4 by 3, 4 by 3, and, right, 4 by 3. We can just write in this way, 4 by 3, 1 plus 4y. Fine, not 4y, it's 4t square and dt. Fine. So how to integrate this? So integrations will be easy now. Okay. This is minus 1 by, we'll just separate the integrations now. dt by, okay, dt by 1 plus dt by 1 plus t square. Fine. 1 by, this is 0 to infinity. 0 to infinity. Fine. dt by 1 plus t square. And this is 4 by 3. Okay. This is 4 by 3. And dt by 1 plus 4 t square. Okay. This is 0 to infinity. 0 to infinity, dt by 1 plus t square plus 4 by 3, 0 to infinity, dt by 1 plus 4 t square. Now both are standard integral, so we can just easily integrate this. Minus 1 by 3, so dt by 1 plus t square. We know this is tan inverse t, and this is 0 to infinity. Fine. This is 4 by 3, right? And this one, this particular expression, of course, you can write it one step. I'll just write extra. dt 1 plus this 4t squared can be written as 2t whole square. This also can be done exactly like this. So only in place of t, here it's 2t. And minus 1 by 3, we'll just substitute the limit together, 0 to infinity plus 4 by 3 into, this is also tan inverse t. T means 2t. Fine, tan inverse t. But only difference is that what is the coefficient of t? The coefficient of t is 2, so it's to be multiplied by half. And we'll just substitute 0 to infinity. Now only thing is left out that we need to substitute the limits. First term is minus 1 by 3, and we'll substitute tan inverse t, tan inverse infinity, that is tan inverse infinity, and minus tan inverse 0. So minus tan inverse 0 is 0. Okay, so we'll just we can write this as once more. Then plus, we'll just cancel this one, so it will be 2 by 3. Fine, 2 by 3, and this is tan inverse, so 2t, so it will be tan inverse infinity, and similarly it will be 0. That is tan inverse 0 is 0. Now it's minus 1 by 3, and tan inverse infinity is pi by 2, and plus 2 by 3, tan inverse infinity is pi by 2. So finally, so it's minus pi by 6. Okay, minus pi by 6. And if you cancel 2, it's plus pi by, okay, it's pi by, if you cancel 2, it's pi by 3. So minus pi by 6 plus pi by 3 is equal to pi by 6. Fine. So this is the answer for this particular questions. And why I say like these sort of questions are why very important, because to answer these questions, okay, you need to know, okay, you need to remember the standard integral. So you should have the concept of partial fractions, okay, and you should have the concept of the properties of definite integral. So therefore, this type of questions are very important. So just discuss another very important, okay, quite interesting questions, alright, and which is going to solve this. That is 0 to pi, which is question number 30. And sometimes these are the questions asked for 4 or sometimes 6 marks. 0 to pi by 4 sin x plus cos x by 9 plus 16 sin twice x dx. Now how to solve these questions is, remember this is 0 to pi by 4. How to solve these questions? So to solve these questions, 0 to pi by 4, okay, 0 to pi by 4, and we have seen that we don't get any help from this function sin x plus cos x at this moment. I'll just write as it is, sin x plus cos x, okay, and 9 plus 16. That we have seen a function that is sin twice x, right? Sin twice x. We know that sin twice x can be written in the form of 2 sin x cos x, right? Okay, sin cos x. And in case if we just go for substitution method, right? So in the denominator there should be a term like, okay, sin x minus cos x. There should be a term sin x minus cos x. Why? Because if we substitute sin x minus cos x t, then differentiation will be cos x plus sin x dx equal to dt. So there is a hope for this, that okay, yes, sin x cos x dx, we can just write dt. But the thing is that denominator, we should get a form of sin x minus cos x equal to t. Yes. So from this, that means the moment you have seen sin twice x, it should come to your mind, okay, 2 sin x cos x. So can we use either a plus b or a minus b formula there in the denominator? But for that problem is with this 16, right? With this 16. So if we can take out the 16, right? So and with the help of the sin twice x, if we can try to form a form in the pattern of sin x minus cos x, right? So to remove 16, so this you have to take help of 9, right? So 9 can be written as 25 minus 16, right? 25 minus 16 is 9. Then 16 sin twice x. Okay, so now see that we'll get a help from this. 25 minus 16 plus 16 sin twice x. But this is the most important step of this question. The moment I just simplify, then you will get the idea and you can solve by yourself, right? 0 to pi by 4. Sin x plus cos x dx. Okay, and in NCERT, you know, like there are many important questions are there. Okay, and then generally the students, they're not of course not by all students, that some of the students that know the examples. So the examples are equally very important like exercise, and please, I just suggest, please do not ignore any question from the examples. Okay, now 25 and take 16, that is minus 16 common, then 1 minus, we'll just get sin twice x. So sin twice x, we can write 2 sin x cos x. Fine. The moment you get a pattern 1 minus 2 sin x cos x, it should come to your mind, yes, we got the pattern. The thing is that only removing 16 will not help us a lot. Okay, so therefore we need we need another 16, so that the moment you take this 16 common, you get a binomial 1 minus 2 sin x cos x. Okay, so just can move to the next steps. Okay, that is 0 to pi by 2 sin x plus cos x dx. Fine. The first term is, okay, the first term is 25. First term is 25, and we have taken a 16 common, and now this is 1 minus 2 sin. So this 1 can be written as sin square x plus cos square x minus 2 sin x cos x. Fine. So 0 to pi by 2. No, it's actually not 0 to pi by 2. So it's 0 to pi by 4. Remember this? It's 0 to pi by 4. 0 to pi by 4. Fine? Yes. This is 25 minus 16. So this particular expression can be written as sin x minus cos x. Can you write this expression? That is sin x minus cos x whole square. Sin square x plus cos square x minus 2 sin x cos x. You can write in this form. Okay. And numerator is sin x plus cos x dx. Okay. Sin x minus cos x dx. And okay, we'll just substitute like sin x minus cos x equal to t. So if we substitute sin x minus cos x equal to t, so it will be cos x, fine, and cos x is minus sin x, it's plus sin x, and dx equal to dt, right? Then the moment you substitute a new variable, you need to change the limits 0 to pi by 4, fine. So if x equal to 0, what will be the value of t? Then t is equal to, if x equal to 0, okay, and t is equal to, what is the value of t? If you substitute 0, sin 0 is 0, and cos 0 is also 1, so it's minus 1. Fine. Yeah, you got x equal to 0, t gives us minus 1. And similarly, if x is equal to pi by 4, x pi by 4, for pi by 4, sin x cos x has got the same value, so t will be equal to 0. So therefore, limit will start from minus 1 to 0. Okay, so we'll just continue now, right? So if we continue, okay, we can just go to the next page. Okay, this will be minus 1 to 0, and this is dt, fine, and this is 25 minus 16 t squared. So let us check the steps. Okay, and when x equal to 0, the t is equal to minus 1, right? And when x equal to pi by 4, t is equal to 0. So the limits goes from minus 1 to 0, and sin x plus cos x dx, sin x plus cos x dx equal to dt. So it's dt 25 minus 16. This is sin x minus cos x is t squared. So I hope we have done that only. Minus 1 to 1 dt 25 minus 16 t squared. I'll just write one step extra, dt, and this is 25 means this is 5 square, and this can be written as 40, right? This can be written as 40 whole square. So this is the standard integral that we have done in the previous class. Okay, what is this integral? That is dx by a square minus x square. I hope that you do remember this formula. This is equal to, right? This is equal to 1 by twice a. 1 by twice a log a plus x by a minus x. This is the formula for this. Dx by a square minus x square is equal to 1 by twice a log a plus x by a minus x. Now, we can just use as it is this formula. Only thing is that the coefficient of t is 4. But if you use this formula as it is, only thing is that after integration you need to multiply by 1 by 4. Okay, so we'll just use this formula as it is. So this is the coefficient of t is 4. Therefore, we'll just multiply. This is 1 by 4. Fine. This is 1 by 4, and 1 by into 1 by 2 into a. A means what? 5. 5 log. Okay, log a minus a plus x, that is 5 plus, okay, 5 plus 40, and 5 minus 40. And we just substitute this minus 1 to 0. So it's done. 1 by 4. That why 1 by 4 already explained that, okay, in case this is, of course, this step I have done directly. In case you want to exactly use this, again you need to substitute 40 is another variable. This way avoiding that steps, because it's use this formula directly, and this to be multiplied by 1 by 4. This is 1 by 4 extra, then 1 by twice a means 5, alright, log a plus b, a minus b, fine. So yes, we'll substitute now. Okay, if we substitute the limits, so this can be written as, okay, 5 to the 10, 40, this is 40 and log. Fine, if I substitute 0 here, 0, so this term, both the terms will become 0, it's 5 by 5, it's log 1. Let's get log 1 minus, we'll substitute minus 1. So if you substitute minus 1, okay, this is log. If you substitute minus 1, it's 5 minus 4, it's 1. And what's the denominator? If you substitute minus 1, so it's 4 into minus 1, that is minus 4 into minus 1 is plus 4, it will be 9. Fine? Yes. And finally, we're just getting 1 by 40 into minus log 1 by 9. Right? Minus log 1 by 9. And this minus log 1 by 9 actually can be written as log 9. So this is the answer for this particular questions, and we have done some important questions of this miscellaneous exercise, and we have got some more questions of this exercise, and let's come up with another video for those questions. And thank you so much for watching my channel, and keep watching, and please subscribe to the channel. Okay, thank you so much.